Hello everyone. Today we will be seeing question number 64 of GATE 2026 electronics. In this question, basically what they are asking is the density of electron diffusion current. Before solving this question, you should know few concepts here. Before that, we will go through the question and then we will see what concept this question required to solve this question. So what they are telling is concentration of electrons in a semiconductor bar varies linearly. Please note down this point. The concentration of electrons in a semiconductor bar varies linearly. Second thing is along the x direction. Concentration of electrons in a semiconductor bar varies linearly along x direction. And y and z direction concentration is not varying, means no change in x and y direction. Then they are given mobility of electrons, that is 1400 centimeter square volt per voltage per second, and thermal voltage is 25 millivolt. We all know what is the electronic charge, that is 1.6 into 10 raised to minus 19 coulomb. What they are asking is density, that is J, and electron diffusion current, not holes. So this is Jn. For hole it will be Jp. And they're asking to round for 2 decimal places. To solve this question, we need to understand few concepts before that. So first concept is types of current in a semiconductor bar. They're told that we have a semiconductor bar. This is our x direction. This is our y direction. And this is our z direction. So what they are saying is here x is equal to 1 micrometer. Here x is equal to 4 micrometer. The concentration of electrons is varying linearly along x direction, not z and y. So what is meaning? First we will understand types of current, then we'll go for variations. Here, what is meaning? What are the types of current we have? In semiconductor bar, we have two types of currents. One is drift current. And the second one is diffusion current. In this question, they're asking diffusion current. This current is due to the external electric field applied or generated. This is due to the concentration gradient. This diffusion current is due to the concentration gradient. This is what is asked in the question. So this we have two types of current, drift and diffusion current. This is the first concept. Second concept is Einstein relation. So that will help us to understand the relation between mobility, voltage, and the concentration gradient diffusion coefficient. Einstein relation. That is dn mu n into Vt. This is electron mobility. This is thermal voltage. In our question, mobility is 1400 centimeter square V1 and S1. Vt is 25 millivolt. This will come around 35 centimeter square this voltage cancelled. Second, right? So we got this is diffusion coefficient. Diffusion coefficient is what is meaning of diffusion coefficient? How fast concentration of concentration of electron or gradient changing. This means how fast or how slow electrons are getting spread. This is the second concept. Third concept we have is Fick's law. Third concept is we have Fick's law. So that is Jn Q into dn dn by dx. This is the electron charge. This is diffusion coefficient we just found out. This is the variation concentration gradient. Here it is given. This is linear. All right. So now fourth concept is variation. Types of variation. First type is linear, which is what given in the question. Second type is exponential. In linear variation, dn by dx is just delta n by delta x as change is constant or linear. In exponential, we cannot do directly this. What we have to do is we have to take concentration gradient. This is the length of that bar. We need to differentiate this with respect to x to get the variation. So in our question, it is given linear variation. We can directly calculate as dn by dx is 2 into so it is delta n by delta x, which is 2 into 10 raised to 17 minus 1 into 10 raised to 16 divided by 3 into 10 raised to minus 4 because it is in micrometer, right? So this will come around 6.33 into 10 raised to 20 centimeter square. Now we need to calculate the electron diffusion current, density of electron diffusion current, that is Q into dn into dn by dx. We know this is 1.6 into 10 raised to minus 19 coulombs. dn we found out that is 35 into 6.33 10 raised to 20. This will come around 3547 ampere centimeter square. Ampere is current. This is centimeter square is density. They are asking for two decimal places. So it is 35.47 ampere meter square, not centimeter, because we have moved the. So this is the answer or solution for this question. I hope you got it. These are the concepts you should know to solve this question. Uh, I hope you got it. If you have any comments, any issues, or any doubt in this question, you can put it in the comments. Thank you so much.